Hello? Testing.
We are here today to talk about dilution. I'm going to introduce everybody, but before we jump into it, I'm actually just curious how many people were in last year's seminar on temperature? Okay, it's actually like, I don't know.
Very few people are willing to endure this twice.
That's not true.
It's like a smattering. There's a smattering
Those that are
in the
here
audience.
again definitely are here with enthusiasm, so I'm into it. Thank you very much for the support. Okay, so the majority of you are not really prepared for the wild ride that you're about to go on, is the only reason I'm asking. And the temperature seminar we did last year is actually a nice precursor to this one, but you don't have to have seen it in order to understand everything we're talking about today. But as you will learn, that temperature and dilution are inseparable friends that have to get along. But there are things that you can do that are really exciting to play around with dilution. So let's do some intros. So I'm Jessamine McLellan.
Started off.
I am the Director of Trade Advocacy and Campari Academy for Campari America. I was at one point in time back in the Jurassic ages a bartender. I went to school for biochemistry and molecular biology, so this is my wheelhouse, and I love to get really nerdy, and I'm probably the only person willing to do this with Dave and Mike. Just kidding. No, honestly, it's an amazing opportunity. But yeah, I've been with Campari now for around 6 years, and it is my joy and delight to introduce Mike Capoferri and Dave Arnold, who are joining me today. Please give them a round of applause.
Thank you, guys. My name is Mike Capoferri, if we haven't met yet, based in LA. Bartender. Spent some time on the Campari team working on the Italian brands, and then opened Thunderbolt about 6 years ago. 6 months ago, we opened a bar called Night on Earth in LA, and then we just opened a brand new shiny one in Denver like 2 months ago called Semi Precious. So if you find yourselves in LA or Denver, stop by. Thank you.
Dave.
Hey, I'm Dave Arnold. My shtick is kind of what was at one time new techniques for cocktails. I had a bar called Booker and Dax. That closed. And then I wrote a book called Liquid Intelligence, which is about new techniques. We're going to talk about some of that. Had a bar, Existing Conditions, pandemic nuked that one. But I now have a bar called Bar Contra, where we actually, like Mike, different program. We can talk about that later. But actually use the stuff that we're talking about today is actually daily use stuff for us. Yeah.
For both of us in very different ways that we'll talk about.
Yeah. Okay.
Great.
So what are we going to talk about today? Dilution is the subject, and we're going to kind of do 3 parts. Part 1 is going to be about foundations. Really, we just want to orient you in the traditional methods of dilution, what actually happens when you stir, when you shake a cocktail, what is happening with ice. Then we're going to move into how to isolate variables, which you'll see is a very fun and interesting thing that you can do to plus up your cocktails. And then last, we'll talk about some more applications, so just kind of like how can you be iterative on that once you've mastered the concepts of dilution in the first place. So part 1, we're going to talk about dilution. So Dave, do you want to define dilution? This is not the measurements, but the definition.
Right. So, this is actually the first thing we started talking about when we were talking about doing this seminar. There's so much glare, I have to take these off. A lot of us mean one of two different, both equally valid things when we say dilution. So unless you define exactly what you mean by dilution, you could be talking to someone and they're going to have really, really whacked out ideas of what you're saying, right? So the two completely logical ways to define dilution, right, are let's look at the finished cocktail. What percentage of that finished cocktail is water from ice, right? That's one way to do it. That is not the way we are going to do it. The other way to look at it is, here is my build volume, 2 3/4, 3/4. Here's my build volume. What percentage of that build volume am I melting with water, right? And so the reason, they're going to talk about how big of a difference that can be in a second, but the reason I do it that way, and we do it that way, is because most of the time when you actually need to know a dilution, what you're going to do is dilute a batch. And so I know the volume of my batch, and then someone tells me the dilution I need of that, so I just multiply the percentage by my batch volume, and now I know how much water I need to use. If you're using total volume build dilutions, then you're like, 1 plus, and then like the dilution equals X is nightmare. Not useful for you. So anyway.
Less algebra.
One man's algebra is another man's nightmare. I think.
You want to review these examples?
Here's a couple of examples. And again, there's no wrong way to do this. I think the important thing to take is that everyone on your team does it the same way at your bar, or else you get vastly different numbers. So sort of the less egregious example here is the first one, a 111 Negroni, right, with 3-ounce build. The way we're going to talk about it today, 25% of that is 3/4 of an ounce. You're going to end up with 3.75-ounce cocktail. Underdiluted for a Negroni, the thought process being you're going to serve that over ice. If you're talking about it the second way, which is percentage of total volume after you add the water, then you'd be getting a full ounce of dilution. So saying the same thing, 25% dilution, there's a 1/4 ounce difference in water in your cocktail. This becomes a much larger delta between the two when we start talking about shaken style cocktails. When we look at a daiquiri with a 3.5-ounce build, if you were to say 30% or 50% dilution on that, which is in the range of what we're going to be talking about today with shaken cocktails, that means we're adding 50% of our cocktail build, 1.75 ounces, for a total of 5.25 ounce final volume. If we were talking about this the second way and you said 50% dilution, we'd be looking at equal parts water and cocktail batch in that cocktail build, ending up with a 7-ounce total volume, 3.5 ounces of which is water. So a vast difference in your final product, depending on how you're talking about it. Is everyone with us so far? It only gets mathier from here.
Yeah.
That was like we were just like dipping our toe in.
By the way, just workshopping this, there needs to be a way to verbally cue people about what you're talking about rather than having to go through this rigmarole every time you train a new person. So doing Q&A, maybe you give us a good idea. What about it's like, dilution of build, like percent of build.
Percentage of build.
Percentage of build. You know what I mean? Like, I don't know. You guys tell us. I don't know.
Yeah.
Well, that's what I labeled it, Dave. So
I can't read that. The angle's too much.
Yeah.
perfect.
Yeah, just take a picture of whatever part of that slide you're going to use at your bar and coach your team.
Just to go back to this, I think really the takeaway is that it is important that you do whichever one of those things. You are that house. You have chosen that house. You were either like House of Stark or House of whatever, like if you want to use a Game of Thrones reference. You're just always doing it the same way and you're not doing it any other way so that everyone on your team understands that that is the definition of what dilution calculations means. Cool? Cool. Okay, so now have you heard of shaking and stirring cocktails, guys? We're gonna talk just to ground everybody here really quick. Stirring is dilution without adding air. Then we also have shaking, which is dilution while adding air, which also happens very rapidly. And then we also have building, so like building in a glass. There's many other things, right? Like blender drinks, frozen drinks. You can also, this is a trigger word for today, but throwing cocktails. You can ask Mike how he feels about that later. But we just want to, these are the main ones that we're going to focus on today. And honestly, we're really focusing on shaking and stirring because those are the most applicable to the cocktails, the vast majority of the cocktails we'd be making.
Can we look at the first slide while we talk about these for a second?
The first slide?
Yeah, that we kind of skipped over, like the very first
Yeah.
one. So when we're talking about those traditional methods, I think it's important to remember this, which is like Dave's quote here. Of how inseparable these two things are. I'm pointing to the far one. There's one over here too. When you're using these traditional methods, chilling and dilution are conjoined, right? You can't have one without the other. When we're talking about shaking, stirring, even building a cocktail over ice, you're not getting it any colder without diluting from ice. Those things are inseparable. So what we're going to get into is how to separate those variables. But I think this is always very important to remember when we start showing all this math. Right now we're just talking about dilution that we're getting from stirring or shaking or building a drink.
Yeah, and we're going to get into this
The weirder stuff.
like kind of like in depth in a minute. But a lot of what we're going to do here early on is there are things that you might know in your head are true. Like, for instance, any chilling you're getting from the ice has to do with the ice melting, right? In your head, you could be like, yes, that's accurate, or like I'm not. But in your heart, you might think, and I see this happen, that somehow there is a difference between stirring a drink and getting it to temperature by dilution and just adding water and chilling. We're going to get into this in a lot, but I'm saying a lot of what we're doing here early on is trying to couple your heart to your head, because your head can tell you one thing and your heart can tell you another. quick example. At the bar, we now take all of our vermouths and stuff, and we put LN to purge all the oxygen in them, and then we cap them. And then my team is like, but I still need to refrigerate them, right? And I'm like, no. They're like fresh. They're like they've never been opened.
Liquid nitrogen, if you guys
and
don't
so,
know what
like,
LN is.
But they're like, no, but you still need to chill because they haven't coupled their head to their heart. And so you just need to run the test with someone, which is what we're going to be working on. Yeah.
This is so touching, Dave.
Separate your brain from your heart. It's very touching stuff. Yeah.
Yeah, okay. Well, let's look at this in applications. This is actually a graph from Dave's book, Liquid Intelligence. You'll probably see a few other things pop up that have to do with that book. Yeah, and you want the laser pointer? Oh, sure. There you go. Go wild. That makes it point.
So, by the way, these aren't my. What this is a list just arranged in finished ABV order of like some standard cocktails. So like egg whites, shakens, stirred, and what I say built here is basically just old-fashioned. It just means old-fashioned, just old-fashioned. And then some carbonateds and some blender drinks down here. Now, it bears repeating, and this is important. These are not my specs at all. This is actually, these are what was considered standard back in the like PEGU, PDT, like, era, because what happened is that everyone who was starting a bar that was friends with any of those people were like, yo, can you give me your classic cocktail list? And they would give us the classic cocktail list and we could like look at their specs. So in my book, like that list of classic cocktails is off of that early 2000s, like New York City cocktail revival group. So some of them have changed, right? So, a lot of us have started shorting sugar on some of these things, or things that we've been doing. But that's where these numbers come from. And the reason that they're important is you see real trends in terms of how diluted. Because a lot of these drinks, some are higher and lower, but they all have roughly similar builds in terms of their alcohol build, right? Like some are higher, Negroni's higher, right? You know what I mean? But like they're all fairly similar. And so what we're going to be looking at is the structure of a shaken drink in terms of how much water. So remember, lower on the graph means more water has been added, right? Because this ABV, high ABV is up here, low ABV. So down here means more water. So we're going to look in here, and you see that the more, and the size of the circle, right, is an indication of how much sugar is in it, right? So you see that except for some outliers, I can't make it point anymore because I can't see the button. If you're up here and you have lower dilution, you see in general these circles are much smaller because they're lower in sugar. So this is the kind of thing we're going to get into. And all of the kind of concepts we're going to talk about today are built around analyzing what happens in classic drinks where you have a complete coupling between dilution and temperature and stirring, right? They're fixed. And that's why some of these classic recipes, they work. But by analyzing classic recipes, we can then figure out how to do fun things once with the modern techniques, we can separate those variables.
Yes.
That make
Yep.
okay?
No,
Perfect.
nailed it. Can I have the pointer back, though?
Oh,
Perfect. Okay, so we're going to get into our first demo. Does size really matter? We're talking about ice here. So I'm going to have Dave and Mike do a little stirring demo. We're going to hopefully prove something to you today about thermodynamics. And so they are going to stir a Boulevardier. The Boulevardiers are exactly the same. And they're going to stir one on KD ice, so cold draft ice, and they're going to stir the other one on pebble ice. And you can think about it, your own hypothesis of whether or not if we stir these drinks to the exact same temperature, which, by the way, we are stirring to 27 degrees Fahrenheit, which is negative 2 point something for the Celsius people in the room. And they are going to do that not based on time. So it'll be based just on getting it to that temperature. They'll strain it off, and then we're going to do some measurements on it. So are you ready?
okay, well, what's the magic number today?
What do you want to start to?
27.
Too cold. It'll take them all day.
Wait, hang on a
Well, that's what the slide says.
Now, we can't measure them until later in the thingamajig, but don't worry about it.
Yeah, so this is a demo we're doing now for technical measurement later, but we're going to keep talking about Boulevardiers after this anyway. So, okay, and the ice itself is actually sitting in strainers so that it doesn't have any water on it as much as possible. We don't have a centrifuge here to centrifuge the ice to get all of the water off it, but you should buy one. Have you heard of the Spinzall? You can't Spinzall ice, can you, in it?
No, you
No.
should not.
No.
Should not. Ready, Rob?
Okay, you guys ready?
Start going.
Okay.
Don't we gonna-
He's not going to go until,
Yours is so slow.
yeah, you got to go.
What
Go,
do we wanna
go.
do, 27 or
27.
27.
Ready?
Yeah. I think you can show the next slide while we're talking about this, Jessica.
Yeah, okay. So we talked about this in the very beginning and also just reinforced it after the traditional cocktail portion of things, but this really is just the same stuff we're talking about, right? Melting is equal to chilling, which is equal to dilution. You can't uncouple them when we're talking about using the energy of ice to do this.
Bastard.
And as you can see, Mike is, are you done? Yeah. And, that's going to be over diluted now.
Hard to strain off of it.
And this one's going to take a lot longer. And that's pretty much what this graph is also showing you. So if they're both going to that 27 degrees.
It's just a thing that none of my bartenders believed me on when we opened Thunderbolt 6 years ago, and I had to do this for everybody and just prove to them that you can stir with Pebble.
But the thing is, like, that's longer. Like, in other words, like, I would typically make a less diluted cocktail than that because I would never stir that long.
It's pretty cold. It's pretty cold for a Boulevardier. 27. Just saying.
Okay, let's see. You know what? The older you get, and when I said this even when I was much younger, the more diluted I like things, often. As long as the structure is still good. Talk about that later.
So what we're gonna do is let these come up to room temp so that Dave can test them. He's gonna take the Brix and Gravity and give you final ABV and sugar and dilution once these come back up to room temp. So we're gonna kind of set these aside and forget about them.
If we were to measure these right now in like a graduated
Oh, in a
cylinder,
vial.
they would also be pretty similar in volume. And the reason that they wouldn't have the same volume is because Pebble Ice holds back a lot more liquid. So it's not that they are different dilutions. It's potentially that they are just, there's ice. Ice is always the problem. Okay, so why does this all matter? I think, Dave, are you going to put those in the test tubes and then talk about this?
These are going in test tubes. These are going in warm water just to come up faster to room temp.
Yeah, my equipment can't really measure accurately things that are cold because they require the temperature of the item to be close to the temperature of the equipment.
It's like a very exciting demo when you have to wait like 30 minutes for the
Yeah.
result. We're trying
The
to just
suspense is
build the
building.
suspense.
Wait.
Yeah.
Okay,
Sit here, wait for it to warm up. All right, what's up?
but we wanted to do it in front of you so that you could tell we're not lying. Okay, so let's talk for a minute about dilution and the impact on flavor. So typically, you saw the traditional cocktail graph. It kind of goes up in ABV. When you get up into the stirred cocktail range, you're talking about concentration of flavor. There's sugar, there's acidity. Those are the kind of 3 bullet points, like if you will. ABV, sugar, acidity are the 3 things that Dave measures for all of the cocktails that he's making and everything that we're going to talk about in this presentation. Of course, there are other aspects of flavor. So there's absolutely other things that are involved in when something is more diluted or less, but they are less predictable and less measurable, including bitterness, which is why we're not going to talk about bitterness today. Well,
You wanted to talk about
I
bitterness.
do. I mean,
Well, I think it's very well, let me know when we should start going on tangents about how to think about bitterness in terms of dilution. Just let me know.
well, we can talk about it after this, but I think right now what we want to talk about is daiquiris and your experiment that you did at Tales a couple of years ago.
Okay, so I don't remember how many years, but it was after the pandemic. We did a seminar on daiquiris with Shannon Mustafer and Julio Cabrera and Garrett Richards about dilution, or about whether or not you should use sugar or whether or not you should use simple syrup. And if you do use simple syrup, should it be 1-to-1 or 2-to-1? And this is because of a long-standing discussion I had had with Shannon over, like, and she's obviously pro-sugar, and so is Julio, and I'm a simple syrup fellow. And I never thought that the small amount of dilution that you get additionally from using even 1-to-1, which is what I use, you West Coast 2-to-1 folk, Any of you guys, by the way, use random simple syrups like 3 to 2 or some sort of demented number?
There's 2 people.
Anyway, okay, so I was like, I didn't really think it was going to make a difference. And the actual number, so if you figure a daiquiri is around 100 ml build, right, a little more or less, 100 mils, which, a little over 3 ounces, it's about a 10% difference. So it's about a 10 milliliter difference, give or take, depending on how much simple syrup you're going to add versus sugar. Because every gram of sugar you dissolve into a cocktail is going to take up about 0.62 something milliliters of space, right? A gram of sugar doesn't take up a milliliter of space in a cocktail. Anywho, so I was like, it's not going to be a big deal. It's not going to be a big difference. But here's something I didn't think about. Shannon and Julio both like less overall sugar in their daiquiri build than I do. So what we did is we made a bunch of cocktails that had exactly the same amount of sugar and acid and rum, and we just tweaked whether or not the finished dilution of the build, the finished amount of water in the build, made it like we had used simple syrup or made it like we had used sugar, right? And it turns out that there was a huge difference in what people thought about whether that extra 10 milliliters of water is in there. And what was very interesting is that people who, like Julio and Shannon, who had lower amount of sugar and a lower overall build volume in their thing, 2 to 1, everyone chose the one that was made with sugar, i.e. the one that had less water in the build. When I used my sugar recipe, right, my daiquiri, which is a 2 3/4 lime, short 3/4 of 1 to 1 simple syrup, right? They were using 10 grams of sugar or some weird like spoon that they use at the bar. But like when you like make it with mine with the simple syrup with that extra 10 milliliters, now with a little more sugar in it, 2 to 1 people prefer the simple syrup version. So this small amount, 10 milliliters build, right, for a 60 milliliter rum base and a 3/4 lime base. 10 milliliters build difference meant the difference between 2 to 1 people preferring it with less sugar in the build and 2 to 1 preferring it with more sugar in the build. And by the way, these were all served at exactly the same temperature. So while it is true that in a classic drink, when you're making it, the more dilute it is, the more ice you've melted, the colder it is. Cold blunts your sense of sweet, right? So that's also making it so that you need to make more diluted drinks sweeter. But even aside from that, when we serve them at the same temperature, 2 to 1 reversal on just that 10 milliliters of water of how much sugar was appropriate. And the more dilution, the more sugar you need per unit booze and per unit acid.
Okay, so
Does that make any damn sense?
All right. Very confusingly, the thing in front of you is not a daiquiri.
Yeah.
I realize that's a little bit of a jarring experience.
Just in case.
Okay, so what I want you to do while you have it and why it's cold, because you can start tasting this in a second. It'll make sense what we're doing, but don't taste it yet before you
gotta
hit
whiz
it with this. This is a shaken cocktail, right? So what we're going to do is sort of mimic the texture of aerating from shaking by using your little milk frother. You have 1 per table.
One per 3 people. So someone volunteers tribute.
You can go ahead and taste this after you frothed it.
Yeah, and it only needs like a little. Bzz.
Mm-hmm.
Yeah.
Yeah,
Yes.
we're going to tell you what it is in a second.
yeah.
We're going to get to that.
Just enjoy this margarita for now, and maybe leave yourself a little bit of it. We have one other thing we're going to talk about before we actually get to what you have in your glass. But since the buzzing is kind of loud, I'm just going to let you all do that. Okay. So. Oh, I forgot we put this in here last minute.
Okay,
Dave.
so this is another good sort of insane graph for Dave to explain, and this is just like a reference point.
Right.
When we start breaking down these recipes for you guys, we're gonna be talking about percentage of sugar a lot. We're talking about percentage of sugar today like a liqueur producer would, as in a weight per volume measurement, as in grams per liter. We are not talking about bricks today. Bricks is going to give you very different results if you're thinking in bricks of a liqueur, and this graph. We're not going to go through this whole thing, is to show the difference between the two, and Dave can laser point.
Ignore all of this. This is a graph that like visually lets you know if you add sugar to liquor, what your finished ABV and finished sugar levels are. But you can ignore that. So if you look here, which is the 0 ABV, that's just like bricks versus, so this is like measuring on a refractometer, right? This is bricks versus
Bricks are green.
grams of sugar. And so you can see that like 2 bricks is not 2 grams per liter, and definitely 50 bricks is not 50% sugar, right? So a 50 bricks syrup, which is right here, is 61.5%. 61? 61? 61.5% sugar, right? And the reason is because 50 brick syrup is a lot denser than water. So a kilogram of, or a liter of 50 brick syrup weighs 1,230 grams. And that liter contains half of that, 600 and something grams of sugar. And so if I'm talking about a percentage, weight in volume, right, there are about 61.5 grams of sugar in every 100 milliliters of simple syrup. So we're always talking about grams in volume because what you are pouring is not a scale. You are pouring a volume in your jigger. So you need to worry about how much sugar I'm adding per unit volume. But you can ignore all the rest of this other garbage.
I don't need that. I need the other thing. We'll get there. Perfect. Okay. So now we're going to jump into isolating variables, which is the first thing we're going to do is talk about a triangle test, which is what our volunteers were up here for. This is called One of These Things Is Not Like the Other. And we served some Boulevardiers, and you actually heard Mike say kind of like what the options are, but just in case you weren't in the room yet, do you want to review?
Yeah, we can run back through it. So,
You have a slide about what a triangle test is and why you should care?
Well, so a triangle,
mean?
I
Do we
can
have that
explain
slide?
it. I didn't make a slide
no,
for
but
it.
explain what a triangle test
So
is, and then I'll explain ours.
A triangle test is a sensory analysis test. It's called a discernment test or a discrimination test because you're looking to try and find what is either different or similar in something. And when you do a triangle test, you need to have 3 variables so that you're really looking to see, can I tell a difference, or is there some is one of these different from the other 2? And maybe what is that difference as well, depending on how deep you want to get into it. Another type of test, a very simple one, is like an A/B test, like a this or that, a Coke versus Pepsi, right? And those are fine, but they don't provide any context, and it really is more about you're comparing one to the other, not necessarily comparing the actual differences between them. So, and if you want to add on to that.
Well, yeah, just try for things that are similar.
Yeah.
A triangle test is the way to go because it can show you whether or not there's any effect at all. If you can't get a reliable, repeatable effect on a triangle test, it's a real good sign that there's not much of a difference. Whereas an A/B test, someone's gonna choose A or B because it's A or B. And so you can get rather spurious results that way, especially when your sample size is low.
Okay, so what we did for this triangle test was we picked 4 lovely volunteers. Please raise your hand, volunteers. Thank you. Round of applause for our volunteers. Thank you very much. Every volunteer was given 3 Boulevardiers, 3 little baby Boulevardiers. We made 12 Boulevardiers, and what we did was stir 6 of them down to 27 degrees and dilute the other 6 exactly to the same amount of dilution. We'll talk about how we got there. That's the nerdy part. And bring that down to 27 degrees in a cooler. So same temperature, same dilution. The options for our volunteers were either all 3 are the same. We sort of randomized who got what. All 3 are the same, or one is different than the other 2. If that one is different, which one and why? And yes.
They're getting served something. You want to tell them what they're getting served?
Oh, okay. Sorry. This is also not a daiquiri. This is another margarita. We're going to go through what it is, but do the same thing. Froth this one, taste it. If anyone has a cucumber allergy, don't drink it. Okay, so.
Or you just hate cucumber?
Or if you hate cucumbers.
These are the specs, but do you want to do the results or?
Well, we can do the specs first. So here are the specs, and when I talk about we pre-diluted this to the level that we stirred to based on the temperature we ended with, this is what we're talking about. So it ended up being 40.1 mils of water per cocktail, which again is much easier to measure when you're with water because you're weighing. We're doing that in grams. A gram of water, a milliliter of water weighs 1 gram. Just to put that out there. If you hear us go back and forth. A milliliter of any other liquid does not necessarily. Also to put that out there. It's only true for water. So 40.1 mils of water went in. We brought this down to 27. We're going to show the whole formula that Dave used to get to that number, but let's talk about results. Oh, and of course, it's utilizing our wonderful sponsor brands, Wild Turkey 101 Bourbon, Campari. There is no Negroni without it. And 1757 Rousseau Vermouth.
Thank you.
Okay. Had to get that in there. I assume my check is in the mail. Okay.
Do you want to talk about what they wrote first?
What's that?
Do you want to talk about what they wrote first,
Okay.
or do you want me to put them up?
All right. We got here. Person number one went on a journey. Person number one used both sides of his paper. And so the journey sort of ended. We got like a strongest to weakest lineup. We got differences in dilution. We got they're all different. Option C, the secret third option. And then we ended with number 4 and number 7 are the same.
Okay.
Do you remember what your other number was? What was your other number? Which one's different? Number 1. So number 1 is different, is what we're going to remember. Person number 1 said number 1 is different. Person number 2, a little more straightforward. Not only do we think number 8 is different than number 2 and number 10, but it's also the best version. Cool. Person number 3, we got some tasting notes. Number 3 is different. I'm going to circle that one. And person number 4, number 6 is different. Person number 4
Oh, they circled it for us.
followed instructions so well. There's a gold star anywhere in the room. We got an extra prize. All right, so let's see how close we are.
Okay. So person number 1 said that number 1 was the different one.
Yep.
So number 4 is actually the outlier on that one.
So what that means is number 1 and number 7 were both stirred. Number 4 was the one that we pre-batched the exact amount of dilution to. Person number 1 guessed number 1 was different. This is not a slight on you, person number 1. These are meant to be very similar.
Person number 2 said that number 8 was different, and number 10 is actually the outlier for that. Person number 3 said number 3 was different.
Nailed it.
Somebody got one.
Did they say they liked it or hated it?
Vermouth more prominent.
Is that good or bad?
No say. Well, it's better than quote unquote watery. So
Right. By the way, we did not tell the tasters like even what we were attempting to measure. So it could have been different builds. It could have been whatever. We did not tell them anything about.
The class is called dilution. I'm going to put it out there. I don't know.
they
On number 4,
usually
dude.
didn't know what they were attending.
I don't know.
Person number 4 said number 6 is different than the other two, and actually number 9 is the outlier.
It's interesting.
So,
Last time we did this, one person in the group got it right also.
Yeah.
Which I think the odds are someone's going to guess
Statistically,
1 out of 3,
someone,
correct?
yeah.
Yeah.
And I measured them after they were done. I use what we use to measure them is this little density meter, which used to be 3 something. I think maybe it's 4 something now, and you have to pay the weasels to use the software. Yeah, and a little refractometer. So you cannot use a refractometer to measure a finished cocktail or a liqueur on its own because you have 2 pieces of information you're looking for. You're looking for the alcohol content and the sugar content. Forget about acid. You can't do all 3 at the same time. You can't. Forget it. So like if you're assuming you're just doing sugar and alcohol, if you just use a refractometer, you have a number that's poisoned by 2 different variables. If you use just density, also you're poisoned by just 2 variables. However, if you use density and the Brix number on a refractometer, then you can use a number of commercially available programs to marry those 2 numbers and get a result. So you can figure out the sugar and alcohol level fairly quickly once they come back up to room temperature. And the one that was stirred ended up at 24.6 ABV with 7.3% sugar, and the one that we diluted with water and just put in the freezer ended up at 24.2 ABV and 72.0 grams of sugar. So very close to each other. Or 7.2%, yeah, sugar.
And what we had the team do was stir all 6 Boulevardiers separately because there's always going to be some user error. Your stir is not going to be exactly the same every time, right? So stir 6 separately, batch them all together, so we're averaging out in case one person stirred way longer than the other. So different people stirred one at a time, put them together.
So I know we couldn't do this test because what a nightmare for all of you. But like, hopefully you saw like 4 theoretically trustworthy people like do the test, and you know, you've seen the results. I actually trust other people's results more than my own. So because I always think too hard about what I'm doing, and like I freak myself out. So I actually really more trust giving other people a test and seeing how they respond. So hopefully now this is helping to link the fact that, yes, you really can just dump water into your batch, throw it in a freezer, and walk away from it.
And the moral of the story.
Freezer, but we'll get to that.
Yeah. Yeah, just to bring it back down to this particular example and all of the other ones where we're talking about dilution, that the key here is that they are ideally the same, right? Like, you don't actually really tell a difference between them. You might have been overthinking it in a triangle test. Like, there's a lot, there's a lot happening. So, but the real goal here is to have there be no difference between them. So if you find that there's a difference, you might be like drawing on pulling straws or whatever. But ideally and mathematically, they are pretty similar.
Yeah, and you have to be careful when you're running a triangle test not to test 2 variables in one. So if you were trying to stir them, but if the one that you had in the freezer was colder than the one that you were stirring when you served it to someone, then your test isn't valid, right? So it's like you have to so these were at the same temperature. The freezer was set to the same temperature we were stirring to. Everything same.
Yeah. Should we talk about margaritas now?
Let's talk about margaritas.
Okay.
And why we were talking about daiquiris when we were talking
Sorry.
about margaritas?
I jumped ahead a little bit, but we are going to jump into margaritas, calculations. Let's talk about those.
But don't wait to drink your margarita.
Math.
Drink your
Let's
margarita
math.
while it's cold.
Don't get nervous with all the numbers. However, I will say that the slug line on this seminar should be get comfortable with some basic kind of cocktail math. In fact, Mike, you were telling me that one of the first things you do is train people up on cocktail algebra and spreadsheets.
Just like the basic solving for X of for Brix correcting and acid adjustment, and for ABV calculation in a finished cocktail. Like, those algebra problems are things you learn very early on.
Yeah, and you don't need to do it in your head. That's why Google whatever.
No, we use a calculator, but you need to know what to plug into the calculator, right? So it's still you need to understand the reason for the math to be able to solve for X. It's algebra 1 is very important if you're going to be batching cocktails. So
these are the current equations I use for classic cocktail shaken and stirred dilutions when I'm doing spreadsheets or databases. And I use them because, for me, they look very simple, right? So what I'm saying is that, in fact, sugar is also important, but not really for what we do. Unless you're doing blender drinks, you can really ignore sugar in terms of how much dilution you're going to get. But what I'm saying is that the amount of dilution you get is dependent on the alcohol content of your product. By the way, when you're punching in ABVs, I think this comes out as a percentage. So these are decimal ABVs, I think. Yeah. So it's a square function because it's not linear, right? So and these are just empirical, right? You don't need to worry about these numbers okay. So it's this number, you multiply the ABV by this, and you square the ABV, you get that, you add that, and it's going to give you the dilution. The higher the ABV, the more diluted it's going to be for a given thing. And you can just take a picture of this, plug it into your spreadsheets. The way the stirred one works is this is the measurement that I did. What I did is I made a bunch of drinks at different ABVs and stirred them, and then saw how much dilution they got, put them on a graph, and said, computer, give me a curve that has a square in it that meets these target values, and it gave me this. And then I did the same for shaken drinks, and I got another one, and the curves were so close to each other that these are actually just scaled by a number, right? These are actually the same equation, just scaled by a different number on the outside. So if you say, hey, Dave, I don't like the way you stir your drinks, you don't stir long enough, you can just multiply this by a number greater than 1, and your cocktails are going to get more diluted. Or if you're like, hey, Dave, you stir too much, you're a dilution freak, you can multiply this by a number less than 1 and continue to use them. Because the important thing is really the relationship between the numbers coefficients, not what the actual numbers are. Does that make any sense at all?
Well, it makes sense to me. So
Don't worry about what the numbers are.
Say it again.
the numbers are based on all the empirical data from all the tests he's done, right? So don't worry about what the numbers are. This is a great starting place for calculating batch dilution. So when we show, we're going to get into a bunch of recipes here, and we show a shaken cocktail, the way we got to that dilution number to know what to add into the batch in your margarita was using that top formula. If you like your margarita more dilute than that, multiply that times 1.1, 1.2, whatever, and go up 10 or 20%. If you like it less, multiply it by 0.8 or 0.9 and do 80 or 90% of that dilution.
Oh, I forgot to mention this. You might be thinking, well, then what the hell good is it? If I have to multiply, here's what's good about it. Assuming that you are a consistent bartender, right? Your style should stay the same. So what you like should stay the same. So once you find the multiplier that hits your numbers for what you like for a stirred drink or a shaken drink, you don't have to rethink about it every time you have a new recipe. You can just plug in what your ABV is and you're off to the races. You know what I'm saying? So it's like, that's why, like, you know, it's good to like figure out exactly what you like, because then you don't ever have to think about it. I can't tell you how many thousands of dollars I have saved in liquor by just knowing in advance roughly what my finished numbers are going to be, or how many hours and hours and hours of dev time I've saved by just knowing a little bit in advance, getting closer, getting to within a quarter of an ounce on my first pour, my first attempt, like, is huge time savings. But you need Excel or Google Docs or a calculator.
Yeah, if you're starting from scratch every time, the R&D will never end. Right?
Yeah.
This is a great starting place to build consistently every time. Okay, now we're going to talk about margaritas.
Well, yeah.
Are we going to get to your margarita?
Yes,
we're going to do
because
it. Okay.
you have 2 margaritas in front of you. What Dave is actually going to blast through right now are some he's going to walk you through that, which is these graphs. Yeah. Ooh, no.
All right. By the way, so this is actually how I make cocktails. This is actually like how I work, right? Don't. I do it in an old database called Access that no one uses anymore. But you can do it in spreadsheets or whatever. But I made this like so long ago that it's so much of a pain. So I said to Jessamine, hey, Jessamine, give me like a person's spec for a margarita with Grand Marnier, a Cata Margarita Lac. And she was like, okay, like 15 is, I do a 30 ml ounce. So here it is. This is what the spec she gave me, right? And I was like, you know what drink I really like? I like the daiquiri. So I was like, okay, I'm going to take my daiquiri, the one I talked about earlier, and I'm going to analyze it. I'm going to say, okay, a daiquiri starts out at about my daiquiri, which is, I'll say it again, 40 ABV rum, 2 of that, 3/4 of lime juice, flat 3/4, so 20 mils of simple syrup, a little bit of salt, so 1-to-1 simple syrup. And so, like, this is what can I have the next one because it's going to show what I'm looking at. This is the targets.
You're holding it.
What? I can't even see the highlighting. There it goes. All right. So this, by the way, this is what you're looking at, the highlight part. And so, like, that's what a daiquiri is before dilution. If you notice, if you look up at the numbers that the regular person, like one is for this margarita, you'll notice that the build volume, a little higher, that's fine, but it's also higher ABV. So it's, by the way, I drink my freaking margaritas in a coupe and I drink them fast. I don't know rocks. So you'll see that, like,
That's a daiquiri, Dave.
all drinks should be daiquiris at the end of the day. So the numbers. This is the finished one. So I gotta go back. So if you look at the original one, which is the original. I can't make this work because I can't see things. Okay. So if you is this no? This is the one I've already done. Son of a bitch. Anyway, the original one was higher in alcohol and relatively acidic. So I used a computer to balance them out. This is how I actually do it. So I sit there and I futz with the numbers, right? So what I do in my head is
Test line is inputting the mils.
Yeah, the test line. So I'm putting in the test line, and you see where it says test underneath, and I'm trying to get that test line to have as close to my target. And this is kind of what I want to point out, is that in my head, I always have a target. When someone says, what drink should we make? I'm like, what do you want it to feel like? And then I load that target. Here's the target. And then I'm like, okay, you want it to fit in the same coupe as a daiquiri because you're not going to put it on ice? Great. It needs to have about the same volume as a daiquiri, and I want it to have the same or similar ABVs, so 24 to 23. I want it to have about the same sugar level and maybe a little more acid than a daiquiri because even though all drinks should be daiquiri, maybe the margarita should be a little tartar, right? And so that's how I come up with all the drinks. I look at the targets, I know what the dilutions need to be, and I know what my starting build needs to be. That's how these drinks were developed. Talk about substitution.
Okay, so this is I think if you go one more, this is what you're drinking. This is finally we're going to talk about the drink in front of you. Okay, the first thing you got, the Cata Marga Dacalac, right? Because this is a Cadillac margarita like rebalanced to be a daiquiri essentially, right? So this is the spec you're having in your first margarita that came out that is hopefully gone by now. So not like built more like a daiquiri, tastes like a margarita. Your total dilution on this using Dave's formula, 57.6 mils per cocktail. So a lot, almost 2 ounces, just under 2 full ounces of water mixed into that cocktail. We did not shake it. We added it, and we brought it down to 18 degrees in a freezer that we modified in the back. So when we talk about separating these variables, because we can do that, we can do some really cool stuff. So what we did to your second one is replace that exact amount of water with cucumber juice. And so no water in this marg, except for the water naturally in cucumber. All your dilution is cucumber juice, and this is like something we do a ton of at Thunderbolt. And just to throw out there, that previous thing is not how I make cocktails. I do not make cocktails on the Starship Enterprise. Like we are still working with a goal. We still have a goal in mind, and there's like a reference point for everything we do. We go about it in very different ways. And it's interesting to see because we ran Dave's test on a bunch of my cocktails, and we end up still back at daiquiri for the shaken things. And so we could have go a different way to end in the same place. But we're using reference points and going. All the math for us is sugar content, alcohol. I don't have the ability to titrate acidity, so we're balancing that by taste, and we still ended up at daiquiri.
Well, daiquiri, delicious drink.
Yeah.
One more thing to mention here is that I just want to show you this because a lot of people are freaked out about how to calculate, and so I forgot to just go through this. So here's Grand Marnier. Grand Marnier, this is the amount I'm adding. It is 40% alcohol, so 0.4 times 15 is 6 milliliters of ethanol, right? 15 milliliters, Grand Marnier is, I thought it was a little higher, whatever. It's 20.3% sugar, right? So like that says 200. I thought it was higher. That number's got to be F'd.
That's right.
All right, yeah. And then so 15 times 0.203 is 3 roughly grams of sugar are in my build now. And you just keep going down. Espolòn, 40%, 18, no sugar. It has 45 mils at 40 ABV is 18 mils of ethanol, no sugar, no acid. 1-to-1 simple syrup, 15 mils at 61.5%. Multiply that, 9.22 grams of sugar. Saline, nothing else. And then lime juice at 6% acid. There's a little sugar. That's actually numbers a little high. I should cheat that back. 6% sugar is 6% acid is 1.833. You carry these numbers down. These are your totals. You divide this by this to get your percentages. And now you know the ABV, the sugar, and the acid levels of your drinks. And so now you can get accurate targets. Don't do this all by hand and a paper. Just throw the numbers in a spreadsheet, calculate them across. But it's once you start thinking this way, and I can give you the numbers for almost any liqueur that you want, right? Because I have them. But if you don't know what the number of a liqueur is, just assume that most neutrally sweet liqueurs are in the 220 to 250 range. Really sweet
grams
things.
Per liter. That's grams per liter.
Really sweet things, Kahlua, are a lot more, and like some really drier things are a lot less.
Frangelico is way more.
Oh, yeah.
Kahlua is way
Anyway,
more.
so like, and it's good enough to get close to the number for your calculations, because all you're really trying to do isn't be right, it's save yourself development time.
Because you remember, you can't get the sugar content with a refractometer of a liqueur because there's alcohol in it and it refracts light. So you need both of those pieces of equipment, or you need to DM Dave, and he'll just give it to you.
DM Dave.
Yeah, just DM Dave.
Slide into those DMs. Okay. Is there any questions about this? Yes.
When you say really high,
I don't remember on Frangelico. Dave
I-
probably
do you
has
have, do you
it.
have my piece of paper?
It's like
Look for the
400
highest
grams
number.
per liter in
Look for the
Frangelico.
highest number that I have in my paper. Do you still have that with you? I
Just
gave
gonna
him my
rummage through
sheet.
my bag in front of the.
They can go pretty high.
Did I bring it?
It's also dependent on like some things that are relatively high in sugar. It depends on the solubility of sugar. So some liqueurs, in fact, there's some like fun European liqueurs that actually have rock candy sugar in them because like they've crystallized the sugar on the bottom. So they're always at the exact solubility limit of sugar at room temperature, of sugar in alcohol at room temperature. Like chartreuse is pretty much saturated. You can't get more sugar into chartreuse green because it's so high in alcohol that you can't dissolve anymore. Think about it this way: mentally, like 67 bricks, right? Like maple syrup is about as high as you can go without throwing crystals. So then you can add straight ethanol to that and boost it up, but you can't get more sugar into the water than about 67 bricks, right? So you can mentally, I forget the name of the hypothesis, it's a guy that starts with an H, but you can separate the idea to within, within a little bit of the alcohol by volume, and then think about like simple syrup sitting next to it at like what its bricks is to get an idea. Does that make, complicated, but
We can't find the sheet.
I can't find your sheet, but so if somebody wants like every liqueur ever and the sugar content, there's a piece of paper like sitting up in the lounge upstairs on one of the tables that I definitely left up there.
Okay.
Okay, so margarita questions. Yeah, good. Cucumber, we get it. We picked cucumber for a specific reason. We wanted to keep the cocktail balance the same, so we added something that doesn't have a lot of appreciable acidity or sugar in it, right? Like a one-to-one replacement for water. So we didn't have to readjust the whole cocktail. Because for this first example of how we can sort of separate variables, I think it's important that only one variable is different. We'll talk about some more complicated ways to further explode and rebuild a recognizable cocktail.
This is your gateway drug into dilution, though. Just the one-to-one replacement of something that doesn't also tweak all of those other numbers. Like tomato water in a freezer martini is another very popular example of that, although it does have some acidity to it.
Stuff and sugar too. Only a little.
Poquito. Okay, so a bird. We're going to talk about jungle birds now.
Yeah.
Surprisingly, not any more daiquiris.
You're about to. It's still not a daiquiri. You're not.
It's still not a daiquiri. You're actually not tasting a daiquiri today.
You're gonna get jungle
guess
birds
what
coming
I
very
balanced the
soon.
numbers
Yep.
to.
Okay, so the cap team is going to go on those. You're going to get a series of 3 daiquiris. I just want to let you.
Nice. Nice. Strong. Got her.
Got me. Damn it. Jungle birds. They're jungle birds. You're going to get a series of 3. The first one that is coming out to you right now is a shaken daiquiri. So we're starting with like the standard.
So good.
From now on, daiquiri equals jungle bird. Okay, jungle bird. Whew. Okay, so it's shaken. The second one that you're going to get is actually stirred. So just buzz only the first one. I just want to make sure that's really clear because we definitely don't want you to buzz the one that comes after this. But the first one is the shaken jungle bird. Should I put all the specs up or do you want to talk? Okay. So let me just, as this is kind of coming out, I'll frame this up. The idea for this experiment is these are different builds of cocktails, right? A shaken drink and a stirred drink and a frozen drink will all have very different flavor profile because of the actual formula that you need to get to have that type of drink archetype, right? Like a shaken cocktail has a certain profile, a stirred cocktail has a certain profile. Frozen drinks also have to be a certain combination of ingredients in order to freeze at the right texture. So all of these things considered, we thought it would be an interesting experiment to take one cocktail and essentially tweak it to the point where it then fits those archetypes, the shaken, the stirred, and the frozen, and sort of show across how the different levels of ingredients need to shift, basically to make it a tasty cocktail. All right, I'll let you explain your specs.
So, well, they're not all mine, but I'll explain
Well-
because Dave's tinkering. This is important. You're going to find out the results of that first demo any minute now. Okay, so we started with a pretty traditional jungle bird. Ounce of Appleton, half ounce Karuba, 3/4 Campari, 1 pineapple, like a fat half a lime. You see 0.6 up there because we were working in mils, closest I could get in ounces. Half an ounce of 1-to-1 simple, little saline. Using Dave's formula, 60 mils of water for dilution. So there's some other variables we have to tweak, and I'm going to talk about all these, and they're just going to just taste them when you get them. They're all starting to come around now because we have more stuff to talk about, and I don't want to do one at a time. So things we did for stirred, and the goal here was get as close as we can on ABV and overall experience. So the perception of sugar to acid, and in order to keep that perception similar, we had to alter dilution, right? So in the second one, choose the stirred bird. This is Dave's spec from Booker and Dax spec.
I think it was Jack Schramm, Mara McGuigan, and somebody else. That's an actual, was on the menu, Booker and Dax spec from circa 2014 or something like that.
So same rum build, drop in Campari a little bit. We clarified the pineapple juice to stir it. We made some clarified lime cordial. Is anyone familiar with Dave's sort of recipe? You guys are all here. You know this guy. Clarified lime juice, brings it up to 50 brix, pasteurizes it, reacidifies it back to lime. Because adding that sugar drops the total acidity, so you need to add acid back. It becomes a shelf-stable cordial, like really baller Rose's lime. So lime cordial, and then also a 1/4 ounce of fresh clarified lime juice that we did not cordialize or pasteurize. A little bit of saline. You can see a significant drop in water here. So because it's a stirred style cocktail, because we want it to read not over dilute, using Dave's formula, this gets, I can't read that, 39.7. I keep forgetting it's behind me too. Okay, and then the last one that's going to come around is frozen. And so dilution gets a little wonky here because, tell me.
There's one thing about cordials, like, I think one of the more recent categories of drink in general is the stirred high acid drink. Because if you look at the classic cocktail specs, there are almost no high acid stirred drinks. And since people have started making kind of more cordials, like more high-end cordials and doing things, I think there's been this kind of like blooming of this whole, and Mike and Jessamine are going to talk about it more in a minute, but of higher acid stirred drinks.
Yeah, it's this weird balancing act of like a higher acid stirred drink is likely also going to have more sugar than a typical stirred drink. This is a very high acid stirred drink, and it's also a very high sugar stirred drink compared to something like a Boulevardier, right? Because we have to balance out that acidity. But similarly dilute. So to like a Boulevardier, it's low, 39.7 mils per cocktail, so just over an ounce, right? 39.7 is an ounce and a fat ounce and a quarter, ish. Okay, and then the frozen that's going to come around. A couple things with frozen. Again, it's really freaking cold. So what was our final serve temp on this one? Like 11?
11.
So this is also, we gave Dave like the blender gag order today. He's not allowed to talk about blenders. So today we're talking about like a frozen machine, like a Granita style machine, is what we made this in. So again, spirit build, the rum build, the same. Campari went the highest it went. We want to up that bitterness. A lot of pineapple juice because we're working with way more sugar and dilution in a frozen cocktail. In this case, I'm talking about pineapple juice as part of your dilution. It's not water, obviously. Lime juice, 0.875. Simple syrup, 0.5. We add a little bit of xanthan gum to give it texture. We add saline. This is also not a seminar about polydextrose, but Dave's new toy. It's like the best. Polydextrose for body. And also what we use it for is freezing point depression. We can talk about that after. And then water. So water's tough. 60 mils in this, but with frozen drinks, you're drinking all your ice, right? So this is talking about water that is still liquid, not water that is frozen. So it's a curious number to look at overall dilution in a frozen drink because there's nothing left in the glass when you're done. You drank all your ice. Does that make sense? Okay. You can read all the ABVs down there. Highest, obviously, are stirred drink, but all within like a similar range and lower, even for a stirred drink, lower than a traditional non-high acid stirred drink where we'd ended up with a Boulevardier in like the 20s. Stirred? Yeah.
Do you want me to go to the next slide or?
Well, should we do numbers first from our demo, or should we keep going and do this at the end, Dave?
Well, it's going to take me another second.
Okay, we'll keep going.
All right. Just a note also, the shaken cocktail was served at 18 degrees, and the stirred was served at 27.
What are the Celsius numbers for that?
Negative 2.58 and negative 7.78. Because I put them both on there, just for you, Dave.
That's Celsius, for you Celsius people.
I can't read that.
I put them both on there. They're both on there. Although I apologize for everybody having to whiplash back and forth between ounces and mils because the cocktail builds are in ounces and then a lot of the calculations are in mLs. So sometimes it's mLs, sometimes it's ounces.
We pour in jiggers. Jiggers are in ounces.
Yeah.
We batch in mils because we're making multiples.
And,
So-
and bottles are in mils.
And
so
by the
it's
way-
way easier. Yeah.
Yeah. Do you want to use this
Listen,
one as well?
No. Listen. Many of us have, I think, this. I don't like this idea of like rounding. You say to yourself, I don't know you, but maybe you say to yourself, hey, listen, you can't possibly jigger that accurately. What's the point? Just give crappy numbers. And first of all, when you're scaling things up, right, you can be more accurate when you're scaling up. And so I'd prefer to have a more accurate number. But also, if you give someone an incorrect target, right, they're always going to be inaccurate around a target that you give them. So why not give them the accurate target to be inaccurate around so that their grouping of stuff is around the number that you actually want to have happen, right? And the reason these all turn out so wonky, any British people here? Yes. All right, so I apologize for our 60 mil bills as opposed to your 50 mil bills over there, right? But the numbers are weird because 3/4, a cocktail ounce is 30 mils. So 3/4, which is the most standard thing you could think of, it's not a whole number, right, is 22.5. So just get used to 22.5. Just put it into your head. Stop worrying about it. And like, I'm going to give you the more accurate number, right? And I think bartenders can accurately jigger down to about 1/8. If you get a decent jigger, you can jigger down to about 1/8 of an ounce. And 1/8 of an ounce, I'm sorry to say, is a wonky-ass freaking mil number. But I'm just going to give you what that is. Because why wouldn't I? Maybe you're going to make 100 of them someday, and you're going to use a graduate cylinder, and you'll be like, oh, I'm glad this is accurate.
I was slightly concerned when you stood up. But we're good. Okay. While you're just still doing that measuring, I think we'll just talk about this really quick.
Yeah, and just to talk about the temperature on those for a second, the way we got to those temperatures, you'll notice you're seeing a couple of the same temperatures over and over again, is we have a couple different freezers back there modified. So the reason we're working at 18 and 27 specifically is because all the stirred stuff we're serving at 27, all the shaken stuff we're serving at 18, because we diluted it in advance, got it down to temp. We didn't stir all those for you individually. The caps did not do that. We spared them. They worked hard enough for this, I promise.
The freezers are all being controlled by Inkbirds. Inkbird, sponsor Mike.
Trying. Anyone at Inkbird, sponsor me.
Okay, this is actually just, we graphed that acid, sugar, and ABV of the frozen, stirred, and shaken numbers, just so you can actually see what those look like in comparison. So that's why when Dave was saying that like the stirred drink is actually a high acid drink, it is. It's higher than the other drinks. So it has the highest acid out of all of them. It's also the sweetest, and it has the highest ABV. But that's because it's also the most concentrated, right? Yeah, least dilute. Anything else you want to talk about on this, or do we want to go to results?
I just think like the range is interesting, right? Like the range of sugar content is interesting to get the same flavor profile across the board. If you're gonna keep the same balance and you are the highest in acid, like the stirred, you also have to be the highest in sugar to retain the same balance as the other two. And frozen will be coming around.
Yeah, and in theory,
Shortly.
it's the same cocktail.
Great.
That's not a daiquiri.
And it's not a daiquiri. Yeah. Or is it? I think let's keep rolling, and we'll come back to Dave. So I would just want to talk about, and I'm going to talk about more cocktails you don't get to taste, like daiquiri. Just some other ways some things we've done at Thunderbolt that are other ways of separating variables. And again, the reason we're showing this is to like you don't have to do it all by math, right? Some creativity can start by tasting, and then you can go to the math and perfect. And like, we do a ton of math. I would say we do more math than like 99% of bars, but we don't start in a spreadsheet. We start by tasting, and then we sort of move, and we get all our numbers in line. And so we showed you the cucumber margarita, and that's to show like a 1-to-1. Like, we took out water, we put in cucumber. A 1-to-1 substitution. But when you start separating out these variables and you kind of take yourself out of the classic Mr. Potato Head method of I'm going to take out this vermouth and put another fortified wine in, and that's my unique cocktail, you can get...
Well, don't talk about Negroni variations like that.
I love Negroni variations, okay? I'm just saying it frees you up to do a lot more and end up sort of back in the same universe. So what I have up here is a Negroni we used to have on the menu just as an example, and you can see this is like very much not a 1-1-1 Negroni, but we end up in a very similar level of sugar, level of acid, level of bitterness, level of dilution to a traditional Negroni. And the way we get there, with the goal of this was to get as much like tropical fruit flavor we could into a Negroni and still have it be a Negroni at the end of the day. So it's only got 3/4 ounce of gin. It's got 3/4 ounce of Campari. We bolster up the ABV with a little bit of rum. We were using Saison Pale for this. We have banana liqueur in there, 1/4 ounce. We're sort of approximating, the sugar acidity of what would be fortified wine in this by using a hyper dry fortified wine like Manzanilla Sherry, but adding some banana liqueur to bring that sweetness back up to where it would be saline solution. And then almost all of our dilution in this comes from clarified pog juice. Obviously a very sweet ingredient, like the Meadow Gold, whatever the Hawaiian brand is, which is store-bought pog juice, right? So that is our dilution in this. Since we use such a sweet dilution, we have to use a very dry fortified wine, like the Manzanilla. We have to use more spirit to bring it back to a typical Negroni ABV. So we end up at what reads like Negroni, but we got there with like a very atypical Negroni spec because we have taken the need to shake or stir this cocktail out of the equation. Make sense? Okay, great. I have one more example. We'll talk about one more, and then Dave has the numbers. So, other one I want to talk about, almost spelled correctly. It's a hard one. Everyone spells this one wrong. Is the Barcelonette. It's a cocktail that's been on our menu since day one. And this is less about substituting dilution and more about intentionally tweaking dilution. And so what we do here is our sour. This is not a seminar about hydrocolloids. We don't use egg in our sours. We make our sweet ingredient, whatever the syrup is in our cocktail, contain methylcellulose, F50 methylcellulose, and that's how we get our foaming. So what we're getting is a super concentrated ingredient in a 40 Brix passion fruit flavored methylcellulose syrup that doesn't have any water in it. Well, it has water in it, but it doesn't have any extra added water from something like egg white or aquafaba. Does that make sense? So we're already starting with a very concentrated cocktail. What we've done is balance this thing to almost, when he ran the numbers on it, almost exactly his daiquiri spec on sugar, acidity, and alcohol, but we got there a very different way. The big key to this is we under-dilute the hell out of this cocktail because I'm storing this in a freezer at 18 degrees. It's already got its acid in it. It's already got its foamer in it. So I don't have to dry shake it. I don't have to wet shake it. I don't need it to be diluted. It's already cold. I don't have to add lime juice to it. So we take this out, we pour it, we hit it in a Hamilton Beach, we foam it, we serve it. It's only got 1.25 ounces of dilution, so 45 mils of dilution, 37.5 mils of dilution. That is almost exactly what we put in our stirred Jungle Bird. It is about what we had in our Boulevardier. So it's a stirred cocktail level of dilution in a shaken cocktail that would typically have at least, like an egg white sour is like the most dilute cocktail you can have. If you look at Dave's chart, we can throw it back up later, it's the most dilute, right? The lowest ABV. What we're doing is under-diluting on purpose to make it an incredibly concentrated passion fruit flavor, yet the alcohol, acidity, sugar are still exactly in balance with the daiquiri, but you get less water in your cocktail. That make sense? So the different ways you can tweak, it's not just substituting other things, it's you can go up or down and rebalance accordingly to net out the product you want. Does that make sense?
Yeah.
Okay, good.
Yeah.
Dave.
Okay.
How close did we get?
Now listen, remember, back and forth tangents. What we're doing right now is going back to the test where Mike stirred on Pebble and I stirred on Cold Draft, and we just stirred to a temperature. Now, we already kind of proved to you that drinks are the same if you just dilute them with water based on the triangle test. But just in terms of actual measurement, though, in terms of stirring down with different kinds of ice and showing that that doesn't make a difference, that all that matters is that you get to the right temperature, they were pretty damn close. Mike's Pebble Ice drink clocked in at 23.8% alcohol by volume with 7.3% sugar, whereas my Cold Draft came in at a whopping 24.7 ABV, almost a point higher, 77.3 grams of sugar. So almost identical. Almost identical. Like within a point.
Within a human margin of error appropriate.
Yeah.
within
Yeah.
a percentage point ABV and within what was the sugar content?
7.3 to 7.3.
Oh, great.
So it's 7.26 versus 7.28.
Okay,
You know what I mean? So it's like almost identical. 23.81 versus 24.7 something. It's like almost identical.
So it's yeah, you're never gonna notice the difference. I will say this: we start with Pebble Ice exclusively at the bars, and there's some things to know. Right? I'm not just saying like everyone should start with Pebble because it's faster. It is massively faster. We also have bars that have intentionally removed any superfluous movement. Right? So none of our cocktails on the menu are stirred or shaken. None of them. But if you order a Negroni, we're going to make it for you, right? Like if you order margarita, we're going to shake it for you. We do these things. You can't. We are a neighborhood bar. We'll make you anything. So when we start with Pebble Ice, you have to build your round differently. Like I think we've all been trained to sort of build rounds with get your glass, your Yari glass, fill it with your cold draft, start that stirred cocktail diluting, then build the rest of your shaken stuff, come back, finish that. So you're like marinating your ice, you're like letting it start, so you're not stirring all day. You do the opposite thing when you're stirring with Pebble. Like at my bar, the stirred happens last. I'll build it, everything else is about to get poured. I drop a little Pebble on there. I most of the time don't even use a spoon. I just pick up the tin and swirl it with my hand and strain because it takes like 6 seconds. It's like extremely, extremely fast. So it's just like a different mindset in round building. There's also a couple other things that happen. You have to strain it right away. When you hit your peak temp, but also there's a lot more holdback. So you have to adjust your wash lines accordingly. Like we got almost identical results, but if we poured them in graduated cylinders next to each other, mine would have been a lot shorter. And so you look at that and you're like, oh, there's less dilution. You got less yield, but it's not the case. The dilution's nearly identical. It's what all the surface area of Pebble Ice holds back in the tin. So your yield is going to be a little lower when you store it that way.
When you bring,
Oh, sorry, go ahead.
when you
Go
bring
ahead, and then I'll go over
When
here.
you bring people into the program who haven't worked in your program before, how long does it take? Because this is, I think people would be curious. How long does it take them to get into their system to be consistent with stirring on Pebble versus stirring on bigger rocks?
It takes a while. Yeah, I mean, it takes a lot of reps. But at Thunderbolt, everyone's we don't have a ton of turnover, so everyone's been there for a while. But when we started, we used measuring cups. Like, we had 3/4 of a cup as our ice scoop. You know what I mean? So you would, level off your pour and put it in there. We would use 3/4 for shaken and half for stirred. And so that's how we used to. But now everyone's, got their own method. Everyone's good. Everyone knows how to stir. And again, because 90-something% of what we sell are menu cocktails, if somebody orders a one-off, I'm not the bar that I don't need all my bartenders' margaritas to be exactly the same. If you're ordering off menu, you probably are trusting that bartender and you want them to make you something uniquely theirs. I don't care. I'm not saying it's bad. I love bars where everything's exactly identical, but that's what we did on our menu. I want the bartenders to have some freedom and some creativity to do dealer's choice and riff and do their thing. So, everyone's Negroni might not be exactly the same dilution there, but it's pretty hard to fuck up a Negroni. Pretty good every time.
That's why it's a classic. We had a question over there you were pointing to.
Oh, yeah, sorry.
Since the dilution happens so much faster with the Pebble Ice, do you think there's more of a risk if you go a little bit too long, if you do 8 seconds instead of 6 seconds, do you find that there's a risk of over dilution as compared to larger ice?
Yeah.
Which, so would you say that's a little bit more, it takes more practice to...
It's just different, right? It takes practice to learn to stir long enough with KD. It's just different mindset. I don't know that it's any harder. You just have to, that's why I say do it last. Because it's so fast so that you can snap it right away. You can strain and snap. So you're not just pouring a bunch of water in your drink.
But also in Mike's dump sinks, you're not seeing a crap ton of
there's nothing.
dead ice in his dump sinks. And you're not having to turn on water to burn the ice that's in your dump so that you can continue to add more ice to the dump.
Yeah, if we didn't do off-menu items, we would waste zero water. You know what I mean? The only time we're dumping out ice is when we make something that's not on our menu.
California.
We need that in California.
Yeah.
We've been in a drought for a million
Yes.
years. I don't know.
A drought.
Yeah.
Are you using a comparable amount of ice, the Pebble Ice and the Yari, that you would use with regular ice?
No. KD, most people are filling that thing. And if you have a Yari glass, right, you're filling it at least halfway up, 3/4 of the way up. I'm using half a cup of Pebble Ice. And we do it, it's even faster what we do because we don't have mixing
This
glasses.
full.
Yeah, we do it in the small tin. Because it's faster in metal anyway. It just gets cold way faster. So we're just it's all
And
about
dilutes less.
It's all about speed for us to go, and then you're done. Yeah.
when you're stirring in one of those big things, you guys know that any ice that's not touching the drink is a waste of your time.
Yeah, like
Right.
anything above your wash line in the glass is just for show. I know there's more questions, and we definitely have time for Q&A. But I want to where are we on the slides?
Yeah, let's go back to Dave's cocktail because we want to talk about
Great.
one of yours.
Also, can I just mention dilution? Because you guys were talking while I was measuring. And on frozen specifically, frozen drink machines are not classic cocktails. Earmuffs. They're kind of based on blender drinks, right? Blender drinks are an act. I'm not going to talk about them other than to say that blender drinks are, I think, the most difficult to do consistently well with normal back bar ingredients because they dilute so much, and there's two problems. One, they have to be very diluted because that's just math. When you're blending it that fast, you're going to get the cocktail as diluted as it can be. It's going to be what we call equilibrium. It's going to reach its temperature equilibrium, which means maximum dilution. However, it also requires a certain texture. We want blender drinks to have a certain texture, which means it also has to have at least about 30% of the cocktail be frozen ice crystals, right? So you're adding a boat ton of ice to this. That ice also needs to get cooled down. And so there's a very narrow window of specs that aren't incredibly sugary that also work, because you can also do that work well as blender drinks. Now, frozen, so, Jessamine was like, but Dave, how do you talk about dilution with frozen drinks? We had this argument today while we were eating sandwiches. And I was like, well, I don't think about them that way. I think about frozen drinks as a better way to make a blender drink. And in blender drinks, you can talk about dilution. In frozen drinks, you think about your finished build, right? So you start with dilution. Dilution is the first thing you start with. What do you want to make? Let's make a liter of frozen drink. All right, I want it to be 10% ABV. How much liquor do I need to add? Boom. Now that comes off of my liter of water, right? How much sugar do I need to add? I'm going to add this sweet thing, this juice. All those come off my build. How much acid? All those come off my build. And what's left is the pure water for your frozen machine. And that's a case where I'm thinking about the total build volume. Instead of dilution, I'm thinking about total build volume, and then I'm aiming for a target. And in fact, they're easier to build than most of the other drinks once you think about it that way.
Yeah, and sometimes there's no water at all. Like sometimes you're working backwards and you're filling in with non-alcoholic ingredients and you're hitting your target ABV and sugar content and there's no water in it. Like we do things like we'll do frozen Mai Tais with like almond milk as the dilution. You know what I mean? So like we're getting that sort of almond flavor in there.
And Mike's targets are lower than mine, right? So targets.
What's your targets for frozen?
My targets for frozen are not above 10.5, 10.6, but like mostly around 10 to 10.5 with a lower ABV thing like a frosé closer to like 9.
Yeah.
And some of my like more Amari-based ones can be down in the like 8 because Amari, you can take the ABV down in Amari. We'll talk about this later because they're so much richer in like flavor and body. And then in a normal one like 10 and a half, I'm usually aiming for about 1% lower in sugar. So like if I'm doing 10 and a half, I'll try a sugar ratio around 9.5 grams per 100 mils percentage. And the acid can depend on the actual flavor of the drink, but in that range.
Which is the Jungle Bird specs.
Yeah, well, he started that
Yeah.
with the target. He types
Yeah.
the target in first and works towards it.
Yeah,
We go a little lower alcohol, but we also go a little higher sugar. But we're also serving like an 11-ounce zombie glass of this thing, so we go lower ABV because it's big.
Right. It's about responsible serving size. We've talked about this before. Like when you're talking about things like this, you figure out your serving size first. How much liquor can I give you and be responsible? And then you can kind of work back from there. We're also jacking it in the recipe with polydextrose, which is going to allow you to lower your ABV. It's just a kind of a miracle ingredient. We can talk about it if we have time, which we will not.
Sponsor Dave, polydextrose. You get polydextrose, I'll get Inkbird.
How many of you people use polydextrose right now? Oh,
Woo,
Jesus
1.
Christ.
Extra
All right,
prize for you. 2.
Listen, I literally make no
Cheater.
money off of this, but
They both work at Bar Cocktail,
Oh,
by the way.
yeah, I was like,
Both of those guys who raised their hands.
I literally make no money, but
I was like, wait a second.
small plug. So what polydextrose is, it's polymerized dextrose, which is a sugar. It's supposed to be dead neutral. Some of them are a little bit sweet, and they're non-caloric if that's a thing you care about in your cocktails. And you can make a 1-to-1 simple syrup with them, and then they add body to your cocktail on the order of simple syrup. So when you're lowering, the more you dilute alcohol, so alcohol and sugar both provide body to a cocktail, so for any of the dilutions that we're talking about, and if something's over diluted, a lot of times, right, it can either be over diluted because you don't have enough sugar in it, or it can be over diluted because you don't have enough alcohol, or both, right? If you're just actually taking a good spec and over diluting it. But a lot of times when I'm either specifically trying to knock the sugar down or I'm trying to knock the alcohol down, it's going to taste too diluted, but you can bring it back by adding something with body. And the two things that we use are glycerin, right? Or polydextrose. Polydextrose is not sweet the way glycerin is, and so you just make a 1-to-1 simple syrup. It sucks. It takes a long time in a blender. Birch and Meadow on Amazon sells 2-pound packages that are they're still expensive.
So
I buy
expensive.
50-pound sacks.
It's like $10 a pound.
I buy 50-pound sacks from Tate and Lyle, and it's a lot cheaper.
There's other things. We use polydextrose a lot, but in our frozens, we're also using like methylcellulose, and xanthan is in this one, but also like maltodextrin to bulk. So we're adding like air. It's almost like getting overrun in a soft serve machine. Like we're like fluffing it up with things like maltodextrin to fill the glass, but also just to get that like really creamy, airy, it's almost like marshmallowy texture.
Also, air, I'm going to get you a sec. Air will also make it last longer in the glass because air is a good insulator, so it'll stop the meltdown on it. Xanthan does the same thing. It immobilizes the ice crystals, and so not only stops separation, but slows melt rate. But don't use the same amount of xanthan in a freezer that you would use in a blender drink, because when you're adding xanthan by the quarter teaspoon to your blender, like most of that is not actually hydrating. And so if you do that, and if you add like all of that into a batch that's going to be sitting around for a long time and fully hydrate, even if it tastes okay when you taste it in the cup, remember that you're freezing 50% or more of the liquid into ice in a frozen machine, and it can taste real chewy all of a sudden when it gets down to temperature. Yes?
So, the polydextrose, would you find that applicable in, ABV cocktails too, to add body? Because that's a problem that I've been having with, ABV.
Yeah, all the time. So before I used to use, so the question, if you couldn't hear what was being asked, was, is polydextrose useful in NA programs for non-alcs? Because it's a problem, the body drops out. Right. So my main issue, and it's not about that, but my main issue with most traditional, i.e. not using new style ingredient, non-alcoholic cocktails, is your choice is either taste over-diluted, poisonously bitter, or, because that's the only way to put flavor in it without adding, right, things like juice or sugar or soda, right? And absolutely polydextrose is going to be your friend to get like your sugar levels down in line with a highball or something not like a juice, and still have the body of a cocktail, along with glycerin. Sometimes you can use them together, or you can use them separately.
And that added point, after I raised my hand, that you were talking about xanthan gum, so would maybe a shear blender be more appropriate to use with xanthan gum than a traditional blender?
For drinks?
For a frozen drink.
Oh, for a frozen machine drink? It's for...
Just blending.
I think if you're making blender drinks a la minute, like in a, right, you're never going to hydrate it in time. So I think everyone just overdoses them, and I think that's kind of the only way to go. You could add it to one of your ingredients if you had like a mix or something like that, and let it go beforehand. But the problem is that adding the right amount of xanthan to a single ingredient that you're going to pour in, unless you're batching your whole cocktail.
We stick blender it into our dilution. We like use an immersion blender and put the xanthan into our dilution, like into the water or whatever we're using for dilution in the frozen. We stick blender it in, and then we add it.
Right, for frozen, that's easy, but for blenders, you always just have to overdose.
So that's what I was talking about with this shear blender, which is similar to an immersion blender, but I think the torque is a little faster.
Well,
So then you wouldn't be able to break up your. You need the blade to break your ice up.
Rotor stator homogenizers can't. It's a very hard problem to take things that are big and make them into things that are tiny over wide ranges of big and tiny. So, like, rotor stator homogenizers are really good at taking tiny things and making them really tiny, but they're not good at taking big things and making them medium tiny.
We've been talking about blenders for 3 minutes now. I'd just like to point that out.
Every time.
Okay, so we actually are running up against time, so I want to make sure we have enough time for a few more questions that might not involve blenders. Dave, do you want to talk about your Candor and Orange?
This is actually a group effort, and so this is another like higher acid. I don't know why there's a foam on top
Also,
of that. It's a stirred
He's
drink.
very upset about this photo, but I got it from the Bar Contra
Like, it's
Instagram.
stirred
So
What the hell? And it's not garnished with anything.
could have sent me a photo. Just saying.
That is our table. That is our table. That is our.
I think
you know,
it's LN on top or something. I don't know.
Oh my God, no, we don't serve LN to people on the
like-
table.
But this was like somebody who doesn't know what they're doing was like, this will look really cool for the internet.
Make it look like cocktail.
Anyway.
Anyway, so what this was it's higher acid. It's also a lower ABV drink. So Fourth Ave, which makes they're fun. They're out of Brooklyn. They make a lot of liqueurs. They made a floral liqueur called Four, and it's like had all these herbs. It was a limited edition. They only made a batch of it. So we still have this drink on the menu. We don't use it anymore. We use Monica Berg's whatever her Muyu Kinoto instead. But they're not sponsoring us, so never mind. But I tasted it, and I said I tasted it, and I was like, you know what? This would taste good with mandarin oranges, not like the real ones in a can, like from the 70s when I was a kid. So we clarified mandarin oranges. We bought big cans of mandarin oranges. They're good, shut up. And we blended them and then clarified them out. Theo, our head bartender, made some wonky, so I can't really describe it to you, mix of quinine simple syrup and poly D, which is 50 bricks stuff. And Glassed is glycerin and stuff. So the Glassed and the Poly D allow us to have a lower ABV stirred drink that tastes just like a stirred drink. And what that allows us to do is jack the amount of canned mandarin orange in it so that we can have a lot of mandarin orange flavor without having to either boil it down, even though it's already pasteurized, without boiling it down or like doing anything kind of wonky. So here we're like, okay, when we knew the flavors we wanted, we couldn't get the dilutions that we wanted and still have a high alcohol stirred drink. So instead, we allowed ourselves to have a lower alcohol drink at the dilution we wanted by jacking it with Glassed and Poly D.
You tell them what glass it is.
Glassed is so champagne acid is a mixture of tartaric and lactic acids, which are the two acids that you'll get in a champagne or any wine really that's gone through malolactic fermentation. So not your whites that are super crisp and taste like green apple, but most other wines. So it's that mix. At 6% acidity, that's champagne acid. But Glassed has a portion of the water that would be in that mix actually be glycerin. So it allows us to add, it adds a little bit of sweetness because glycerin on its own is about as sweet tasting as simple syrup, 1-to-1, almost. So it's not all glycerin, so it pours really easily as well, but it's a way to add acid and body at the same time. And you're like, Dave, you always say you should separate variables. Why not with Glassed? Well, I'll tell you why. It's super convenient to have around at the bar because almost any Amaro-based drink is nice. And I use it anytime I don't want to add more citrus. I want to add something that's more winey to it. And so Glassed is just a real miracle for low ABV drinks where I'm going to use, like any sort of Amaro, anything like that. I love Glassed.
Okay. Yeah, that is our, we talked about this, we proved this. Does everyone agree that the size of the ice doesn't matter?
The important questions.
Yes.
Let's answer them.
Okay. Thank you so much, everybody. If you wouldn't mind, do us a favor and scan this QR code. And it's our survey.
Only if you like it, though.
Oh, yeah. Especially if you don't. And if you want to hear Dave talk more about blenders, no, I'm just kidding. There is a question in there, which is actually like, what would you like to hear from us for Tales of the Cocktail in 2026? We did temperature last year. We do dilution this year. Daiquiris and blenders.
They're all daiquiris.
Anyway. I know, texture. I actually think texture, it might be texture. It could be texture or acid.
Are we doing questions though or no?
No, oh yeah, we can do questions. But yes, so if anybody has questions, I know we also have to get out of this room in a few minutes. So we will be outside there hanging out. If you have also brought a copy of Liquid Intelligence and you want Dave to sign it, he loves that. All of those things. But we can actually be outside so that the caps can clear this up, and we'll take some questions out there. Cool.
I made you guys the shirt while you were.
Oh, I love it. So good. Oh, God, I love it.
Thank you guys so much for your time. It's been a huge inspiration.